Okay, YouTube, in this video we're going to highlight three very critical properties when it comes to logarithms, and these would be the product, quotient, and power property respectively. And of course we're going to start over here with our product property, but basically as you read through these, we're going to be looking at the property on the top first, and then these bottom properties basically just highlight the same property but written specifically in terms of the natural log or log base e. So looking at all of these properties, I suppose we'll start with this product property here. It gets its name from the fact that we're looking at the log of a product. Okay, and whenever we have log base, we'll go with a base of a here that's a positive base and not equal to 1. Basically, log base a of some product u times v. The interesting thing about this is we're allowed to rewrite this in what we call an expanded form. And this would be equivalent to saying log base a of u plus log base a of v. And so you'll notice that the only difference here is that we took this product and we rewrote it as the sum of two logs. Now, things to note here. These two logs have the same base a, the same base that we started with over here. It's just that we were able to split these up and write it as the sum of two logs. And I notice that I only have simple parts in our argument here. I have no longer any products. So looking at the quotient property, the interesting thing is this. When you take the log of a product, you write it as the sum of two logs. Well, when you take the log of a quotient, u over v, we can write it as the difference of those two logs here. So we have log base a of u over v as our quotient, can be rewritten as the log base a of u minus the log base a of v. Or in other words, the bases, again, stay the same here. And instead of writing a quotient, we're going to split this up into the difference of two logs, where u and v are the respective parts of the quotient. Now, one very important thing is this. If you were to write log base a of u over v, in a rewritten form, order does matter here. That is to say that the u part here has to be the first one of these logs listed in this difference over here. And the quotient part here, the under part, would have to be the part that you're taking away in this difference here, the second logarithm, okay? And so then our power property, which is probably like, my favorite property because it's really easy to do, but we say log base a of u to the power of n. If I have an n out here, what we're going to do is we're basically going to take this n and we're going to throw it out in front. And we get log base a of u where the n is in front. So n times the log base a of u, where again, the bases stay the same. So one thing I'm going to do before we kind of use these properties is point out the fact that yes, all of these indeed have equivalent expressions down here, or equations, all written in terms of the natural log. I would kind of push people towards that natural log as much as possible if you're doing change of basey type things. Otherwise, let's just kind of use the base that we're given. So the two reasons why most often we use these properties of logarithms, to solve equations or to rewrite expressions into a simpler form. So one thing we're going to practice here is this, expanding logarithmic expressions. And that's exactly what we're seeing here. For all of these properties that you saw, we started with a logarithm of either a product, the log of a quotient, or the log of a power here. And what we're doing is we're expanding it into an expression that is made up of many more simpler logs than what we started with, but is indeed expanded, okay? So we've rewritten as product as a sum, or a quotient as a difference, or this power we've rewritten as a product of the power and the log itself. So what we're going to do here is we're going to look at these logs. I'm going to go ahead and quantify these, and I'm going to make some suggestions on as to how we deal with them, okay? So first things first, when we're expanding, you're going to want to write this order down. The first thing we always look for here are quotients. Quotients. Do I have any quotients that can be rewritten as differences? And then I would look for products. Okay, products. This will make more sense when we do these examples here. And then we say 3, last, we're going to look for powers. Okay, so when I look at log base 4 of 5 times x cubed times y, the first thing I'm looking for is, do I see any quotients in here? Like, is this all over a 10 or something like that? Well, it's indeed not over a 10, so we say that quotients-wise, there's nothing that we're responsible for here. But I do notice that number 2 on my checklist, I see not just one product, but 2 products. So according to this property of products, it says if you take the log base something of a product, you can rewrite this as the sum of all of the different factors in that product, the logs of those things. So when I look at this, I say log base 4 of 5 times x cubed times y. I would rewrite this then as the log base 4 of the first thing in the product, which is our 5, plus the log base 4, okay, it's important our base stays the same, of x cubed, plus log base 4 of the last thing in our product, which is our y. So now at this point, when you're going through an expansion process, you're looking down the list, you say quotients are done. Now I'm looking in here, do I see any more products inside these logs? And I don't see any products inside there. So now we're looking for powers. And I notice that only one of these terms here has a power, this one right there. So when we rewrite this again, you could roll your eyes because we get to rewrite all this stuff and it didn't change. The only thing that's going to happen is that 3 is going to come out in front here. We say log base 4 of just the x part now. We put the 3 out front using our power property here that said if we take log of something to the power of another thing, we can put that other thing out in front. So we'd say now plus this log base 4 of y. So, usually I get this question, we say, well, how do you know you're done expanding? Because we just had to expand there twice. What you're looking for is the argument inside the logarithm. And we're looking for anything that has, first of all, a quotient, no quotients. How about a product? No products. How about a power? Don't see any powers, okay? At least all the powers on these are 1s. And I would ask you to think, well, what would happen if you put all those 1s out in front? Well, 1 times anything is itself. So that would be one expansion right there. Let's take a look at this next expansion. Now, I really want to look at this one. Most importantly, because what we're going to have to do here, it's kind of a necessity, is that we're going to have to convert this radical notation, oops, let me get that out of the way here, this radical notation into a rational exponent notation. So just a quick reminder, whenever you have x to the power of a over b, this is kind of the equivalent statement as x to the a power bth root. So for instance here, if I have the square root of x, this is x to the first power and this is the second root, that's the same as x to the 1/2. So we do have the square root of this right here, which is this quantity to the 1/2 power, and I notice I have a quotient. So now I'm going to give you this advice. Whenever you have radicals and you're dealing with logarithms, rewrite it as a rational exponent first. But now that we have it in this form, what we're going to look for is, do we see any quotients? And yeah, we're taking the log, a natural log at that, of a huge quotient. So we're going to say, well, let's rewrite this then is ln of everything in the top part of the quotient. You'll notice that when we do the quotient property, we say ln of u over ln of v here. We're going to rewrite that as the difference of ln u minus ln v, but the u part of this expression here is everything on the top. So what we're really going to get is ln of, in parentheses here, 3x minus 5 to the 1/2 power, that minus the ln of 7. So here I am saying, do I have any more quotients? Well, no quotients. How about products? So 3x minus 5 to the 1/2, I don't notice that's being taken times anything, and neither is my 7. So products are done. Now I'm looking for powers, and I notice that this 3x minus 5 has this giant rational exponent right here. So what we're going to do is we're going to put it out front using our power property. And so our properly expanded form of this would just be this right here, minus ln of 7. So one last comment I want to make on this expansion is this. We can't do anything with this product right here. And if you're wondering why, it's because everything inside this logarithm would have had to have been a factor of a product, or in some way involved in a quotient. I notice that there's a difference here, or subtraction going on. So that kind of splits up the constituent parts, and we would interpret that as not being expandable. So this would be our most expanded form, because I notice that in all of my logarithms I neither have quotients nor products nor powers. So now, just like we can expand out one way, what we're going to do in this last video is going to work on condensing a logarithmic expression using these very same properties of logarithms. So without further ado, let's take a look at this first expression. We have 2 times the ln of x plus 2 minus the ln of x. So the first thing I want to notice here is this. When we expand things, we go through an order that is quotients, products, powers. If we're going backwards, then most appropriately, it seems to me that we would put the powers back first, then the product, then the quotients last. So when it comes to condensing, I'll maybe write condensing here. When it comes to condensing, we're going to work on putting powers back first, then products. We can always remember the products in the middle. And then condensing, let's put our quotients back last. So when I look at this and I say, well, do I see any powers, products, or quotients? The interesting thing is we're looking backwards like now. So when we say, do I see any, I guess I'm waiting the slide to go back here. Here we go. When we see any products, quotients, or powers, what we're looking for now is there anything being multiplied out in front of the log is our power. Anything with our product, we're looking for any sums, okay? And then quotients, we're looking for differences last to go backwards. So in this particular case, we would say, looking at this, I notice that this has a number out in front that's being multiplied by it. So the first thing we're going to do is we're going to replace that up here as our exponent. We say, well, this becomes now the ln of x plus 2 to the 2 minus the ln of x. So now the next thing I'm looking for, I've done my powers now. Say, do I see any products or sums? And I don't see any sums or products. So I'm going to cross that off the list. I'm going to say now, quotients. Well, definitely there's a difference here. So we're going to look at this as being like our u part, and this as being like our v part when it comes to our law here, our property that says, hey, the ln of u over v is ln of u minus ln of v. So in this particular case, we would say, knowing that that's u and that's v, we're going to say we get the ln of u over v, which in this case is ln of x plus 2 all to the 2 power, and this is all over x here. And this would be our condensed logarithmic expression. And I know this because all of our powers are put back. All of our products have been taken care of. There's no sums and there are no differences. So we've condensed this into a single log. Okay. So now looking at this last expression, this one's a little bit trickier, I would say. But the fact is that this 1/3 out front, you could think of this as if we were to distribute this through, each of these logs would have a third out front. So what I want to say is that this 1/3 applies to everything in this expression. So the first thing we're going to do is put that 1/3 back. So we'll say log base 2 of x to the 1/3 power plus now log base 2 of x plus 1 to the 1/3 power. So now looking at this, I say, okay, well, what's next? Products? Well, I'm looking for sums. I notice that I do have a sum here. So everything over here and everything in this logarithm here, these are like our u and our v here. And so because I know that with our product property, we say log base 2 of something plus log base 2 of something is log base 2 of the product of those two things, then I'm going to say in this case we get log base 2 of u times v, where u is this x to the 1/3 times now x plus 1 to the 1/3 power. So now everything is written as a single log. So my last piece of advice is going to be this. It is going to be that, hey, when you have rational exponents and you've condensed an expression, let's rewrite this again then as radical notation. So we say this is the cube root of x times the cube root of x plus 1. And if you were interested in it, yes, you could go ahead and multiply these quantities on the inside. We could get log base 2 of the cube root of x times x plus 1. We only could do this because they have the same indices here. Important for me is that you can get to this step right here. But those are the properties of logarithms, and that's how we use them to both expand and condense expressions. Cheers.